So I'm going to look at several more examples to just show some issues that can come up with factoring trinomials. The general idea here, looking at this expression, I want to find a pair of numbers that multiplies to equal 24 and adds to equal negative 10. So since this is a positive 24, two numbers that multiply to equal positive 24, they have to have the same sign. So the two numbers will have to have the same sign. Because they add to equal a negative number, I know that the sign has to be negative. So this is a little bit different than our first two examples, because here we had a plus sign, so plus 12 told me that the two factors had to be the same sign, but because I wanted them to add to positive 8, the sign was going to be positive. So the numbers were positive 2 and positive 6. Because the two factors have to multiply to equal positive 24, I know that they need to have the same sign, and then because they need to add to negative 10, that sign has to be negative. So if you think about 24, we can think about factor pairs that multiply to equal 24. I know they both have to be negative, so it could be negative 1 and 24, but that doesn't add up to 10. Negative 2 and negative 12, that adds to negative 14. Negative 3 and negative 8, we're getting close, but that adds up to negative 11. Negative 4 and negative 6 are the two that we need. And so it turns out the factorization is x minus 4. Sorry, I should say y minus 4. Sorry, I changed my variable there. Y minus 4 times y minus 6. So that would be our factored answer. We can always check by foiling that back out. In the next example, we have almost the same trinomial, except this time there's a negative 24. And so that makes a big difference. So with a negative 24, that means that the two factors are going to have a different sign. So one number of the factor pair has to be positive and the other number has to be negative. So then if I look at the middle number, since it's negative 10 again, I know that the larger factor has to be negative. Right? Because when I add them together, if one number is positive and the other number is negative, when I add them together, the sign of the larger number is going to be the sign of the answer. So the larger factor must be negative. So let's think about 24 again, and think about the factors of 24, 1 and 24, and the 24 would have to be negative. If I add those up, I get negative 23, so that's not what I want. If I look at 2 and 12, the larger factor has to be negative. Positive 2 plus negative 12 is negative 10. So ding, ding, ding. Ring the bell, because that'll work, right? And so the factor pair that I want is m plus 2 times m minus 12. And again, we can check using FOIL to see that that works. M times m is m squared. I get negative 12m multiplying the outside terms and positive 2m multiplying the inside terms, and so negative 12 and positive 2 gives me negative 10m. And of course the last two terms multiply to equal a negative 24. So factoring is kind of a subtle art, more than multiplying out is just kind of something that we can do a little bit more automatically. But with factoring, you need to be a little bit more careful. Pay attention to what we have there. The fact that this is a negative 24 versus a positive 24, even though everything else is basically the same. The variable changed from y to m, but that really doesn't change too much, the process. So the fact that we had a negative 24 made it a very different factorization. Again, I encourage you to pause the video to try to think about the next one. The next two, I should say. We have to be a little bit careful with these. For the next example, we need to think about a common factor of all three terms, And for the last one, the order is a little bit different than we might expect. All right, well, let's take a look at the answers for these last two. Again, feel free to pause the video if you want to try them on your own first. So with this example, it's a little bit different than the earlier ones because there's a b in each of the terms. So I want to think of that, if there's a common factor, I want to factor out the greatest common factor first. And that's something that you should always kind of be looking out for. If there's a greatest common factor that I can take from all of the terms, if there's any factor that I can take from all the terms, I want to remove that first, and then factor what's left. So if I factor out a b from each of those terms, I'm left with b squared plus 3b minus 54. And so that b is going to be part of our final answer. I don't want to forget about it. But what I can do is now focus on just factoring what's left, in the parentheses. So I want to factor what's in the parentheses. So, as we've done, I have a 54, a negative 54. The negative sign is important. That means that the two factors have different signs. And the fact that it's a positive 3 means that the larger factor is positive. So basically I'm looking for a factor pair that has a difference of 3. So 54 is our number. 54 has a bunch of different factors. So I can kind of work through, maybe it comes to mind what the value should be, but if it doesn't, we can just kind of come through, we can work through the list. 1 times 54 is 54, 2 times 27, 3 goes into 54, so 3 times 18. Does 4 go into 54? Not quite. 5 doesn't quite work, but 6 goes into 54 9 times. Again, I want the larger factor to be positive, so I should think of this as a negative 1 times 54, negative 2 times 27. And so the factor pair that works, looking at this list, negative 6 times positive 9. If I add those two up, I get a difference of positive 3. So there's still a b as part of my factorization. This b, sticks around. It's going to be part of my answer. But then what's in the parentheses, it becomes b minus 6 times b plus 9. So now multiplying this out, I would want to use the associative rule. Right? So basically I have 3 things that are multiplied together. So if I wanted to check my work by multiplying this out, I would encourage you, in order to check, you would want to multiply maybe the b minus 6 and the b plus 9 first, and then this b would then distribute to each of the terms. So that's the factored form of the answer. We could multiply it out to check. In the last example here, the order is different than what we usually would expect. So I have the square term at the end instead of at the beginning. I can rewrite the order of the terms as long as I'm careful. The negative 2 essentially means I need to always keep that minus sign in front of the 2, and negative 63, of course, is going to be a negative 63 at the end. So I'm looking for a pair of factors that multiply to equal negative 63 and add to equal negative 2. So think for a moment, are the factors going to have the same sign or a different sign? So the factors will have to have a different sign, because this is negative, because the 63 is negative, and the larger of those two factors is going to be negative. So it might come to mind that 63 is 7 times 9. Since I want a negative 63, I should make that a negative 54. Since I want to make this a negative 63, I want the 9 to be negative, because then adding that up will give me a negative 2. So the factorization is t minus 9 times t plus 7. And again, we could check our work by multiplying that out, and we should see that that's the right answer. Well, I hope you enjoyed the video. Thanks for watching.